Hello and welcome back to an episode of Haskell coding. So far in the FASTA algorithm, I think we've completed 3 steps, and now we're on step 4. Step 4 is region join. So I'm going to show you what that is. Size 24. So at the end of step 3, we have a bunch of diagonal infos that have an index and start and stop indices into the strings. And what step 4 is possibly replacing each diagonal info with a region, where a region is basically a joining of 2 diagonals. So I changed the example in the scrap file here, but pretend we have 2 strings A, B, C, D, E and A, B, D, E, F, C, D, E with these diagonals, and in this example K is 1. So what this step attempts to do is make each diagonal even better by joining it with diagonals that are close. And there's a gap threshold that's hard-coded in. So you might say try joining each diagonal with diagonals up to 3 diagonals away. And that would correspond to 3 diagonals to basically the left and 3 diagonals to the right. And there's also an associated gap penalty, where you can either have each character of a gap have a certain penalty, or there's the dampened gap penalty version. So if my gap penalty was -5, then the joining of this diagonal with this diagonal, because there's 1 character in between, would be the score of this, which would be 10 if we're using a hit score of 2, plus another 10 for this diagonal, minus, let's say, 5 for a 1 character gap there. If I were to join this one with this diagonal over here, there's a 3 character gap, so that might correspond to like -15, 5 per gap. Or it might you might use the dampened gap penalty and say the very first character in a gap has some penalty, let's say 5, and then each character after that has a slightly smaller penalty, like -4. So those are going to be constants. And this is also all explained in this PDF here. So yeah, let's get to it. Okay. So I'm going to need a new data type, and let's call it region data. Oops. And it's either going to represent a single diagonal or the joining of 2. Okay, and I'm also going to want to know, because I basically want to keep the best region for each diagonal, I want to be able to score these things. So region score. Oops. And a region score is just going to be, for a single diagonal, it's just the single diagonal score, which is inside diag info, using a lens operator getter there, and region score this is going to be diag info 1 score plus 2 score plus the gap penalty of the gap size, and so gap size of the two diagonal infos. Or I'm just gonna call this gap size, where gap size equals okay, so this obviously is not going to compile. Let's fill in the gaps. So I'll start with gap size. Oops, no. Okay, and how we know the gap size between two diagonal infos is just, remember we have, what do we have? We don't actually have the index. Oh. Well, it looks like the index of a diagonal is stored in the key of the map I was keeping earlier called diagonal scores, but that doesn't do us any good, really. So I don't really want to pass around this map everywhere just to get at the indices of the diagonal. So it kind of makes sense to me right now to just add this as a field. And so a diagonal info knows its own index. And there'll just be some slight redundancy there because the map is going to have the index as a key, and then also the value is going to have the index in it, but that's okay with me. So let's go ahead and finish up gap size. And it is just going to be get the index of this one, subtract the index of that one, and then of course absolute value of that to get the gap size. Okay, one other thing that I haven't done yet is this gap penalty function. So this is going to depend on the hard-coded constants. And the gap penalty, is going to take a gap size and return an int. And it's just going to be the gap start penalty plus gap extension times gap size minus 1. So the starting a gap costs gap start penalty, extending the gap costs gap extension penalty per character. Oops. Say -5, oops, and -4. Okay, I'm going to try compiling this and find the errors. There's a couple. Okay. Modify. Oh, right. So I changed what a diagonal scores is. So I think I'm just going to have to, when I create a diagonal info is what I changed. So before it only took 3 fields, the score, the start, and the stop. But now right here is going to be the index it's at, and that's also the key. So I'm just going to pull those out into a variable, and place the key and put that right here too. Oops. Okay, let's see if that compiles. And that is not supposed to be capital I. Okay, only warnings. So, bit of refactoring here going on. Where was I? So, what did I? what did I just do? I did the gap penalty and the gap size. Oh yeah, I was making this region data type and scoring it. Okay, so now I'm able to score a region. So I'm going to start writing the function that, given a diagonal scores, spits out basically a similar map. I'm going to go back up to the top here. So I'm going to make a region scores, which is going to map indices to regions. And what essentially is happening here is I'm basically mapping over my diagonal scores map, and I might as well just keep the original indices. And this diagonal info right here, sorry, this was okay. This was not a diagonal info. A diagonal info has a score, and a start and an end, and then the index is part of the map. But now I have the index in here. Anyways, and we're gonna map those to regions, which again is possibly a combination of two diagonals. So I'm just gonna have a map similar to diagonal scores, but for regions. Okay. And then my function is going to be calculate regions. Okay. So given some diagonal scores, basically want to map I basically just want to map each diagonal info to a region. And this is going to be okay, so one other parameter that's going to be given to us is the how far we want to look left and right. In other words, how large of a gap we're willing to tolerate, and possibly replace a diagonal info with a combination of two with that gap size or less. So that is going to be a gap threshold, and let's just say that's 4. So if I'm at some diagonal index 5, I'm going to try combining it with indices 1, 2, 3, and 4, and then also 6, 7, 8, and 9 is what that means. And so I might as well define basically a list gap deltas, which for a gap threshold of 4 is basically going to be -4, -3, -2, -1, 1, 2, 3, 4. That's what I want this list to be. So it's just going to be take gap threshold from negative gap threshold, and also append that to taking gap threshold from 1 dot dot rather. So and the reason I don't want the 0 is because that doesn't really make any sense to combine diagonal 5 with diagonal 5. So there are my deltas. Let's see how I can use those. So now I get to sit here and ruminate. Well, I want, so I have my original diagonal scores, and I'm going to need to filter that down. So I think I'm going to need an extra parameter here. Oops. And I'll just add it here real quick. And so I'm going to search the original diagonal scores, and well, I'm going to filter the original diagonal scores, keeping only the diagonals I care about. So right now I have the deltas, but I need to change the deltas to be actual indices. So let's go ahead and make a variable, dag indices, and that's just going to be adding to each. This is going to be a map over gap, what did I call it, gap deltas. So I'm going to add to each gap delta my diagonal info index. Okay, now I want to filter my diagonal scores, and map.filter, how does this function work? Filter. Okay, I want the key on the left hand side, so I need to use filter with key. And key value, I don't care about the value. And I want to keep the ones where the key is an element of dag indices. Okay. Ugh. So now what I want to do is check each of the combinations of my diagonal info with every diagonal info in this new map. Create a region of both diagonals and then compare that region to the best one that I've found so far. So I'm basically reducing this. It's kind of like a reduction from an entire map of possibility, an entire collection of possibilities being a whole bunch of double diagonals, and reducing it to one. So obviously I'm going to use a fold here. So, and map.fold takes a function that takes an A and a B. So my A is what's in the map right now, which is diag info. My B is going to be region. So I need to take a function that takes a diagonal info in a region and returns a region. So dag info with a tick so I don't get shadowing warnings. And this is my accumulated, basically best region so far. And I want the better one. So my region right now is a region. My diagonal info prime, I want to make a region out of that. With my original diag info and the one the current one of my fold. And I think I'm just going to compare regions on their scores. So this might look something like let region 2 equal that in if region is greater than region 2, then region, else region 2. But this is just a really bad and verbose way of saying max. So I'm just going to use max and take the max of the region of what I wrote earlier. And obviously this is going to require me to make region an instance of ord. And my initial value for the accumulator is just the single diagonal of diag info. And the last parameter is what now? Oh, my original map, D's. No, D's prime, because it's the filtered map. Okay, so, hey, my cat's licking me, yay, licky, catty, kitty. So I need to make region instance of ord, just kind of like above. Minimal complete definition is either compare or less than or equal to. And I'm going to use my handy dandy notebook. Compile. Errors. 164. Couldn't match expected type or region. What? Diag info is a diagonal info. Diag info prime. I am mapping over diagonal scores here. Oops. Oh, 164. Oh, okay, same line, yeah. I see that. Double diagonal? What, did I mess that definition of that up? I don't think so. Diagonal info. Let's see. Oh, this isn't a function, it's a constructor. My bad. Okay, that's better. So now, excuse me, let's go back up here. No instance for EQ. And just say that regions are equal when the region scores are equal. Try compiling. Okay. And now only warnings. Hooray. Okay. So I have what now? Oh, I think I'm done. Yeah, I mapped the diagonal scores to region scores, and it's compiling, so all I have to do now is see if it works. So I'm going to change my hard-coded S1 to be A, B, C, D, E, and this one's going to be this. And then I'm also going to have a diagonal scores prime, which, just so I don't have to type this in GHCI, this is going to be the rescored, what did I call that function? Rescore diagonals takes both strings and the original scores. Okay, so S1, S2, the original diagonal scores. Okay, so let's try it out. Oops. Ignore all that. F size 24. Okay. So I have my oops. So I have my diagonal scores. That doesn't look right. Oh, I probably forgot to change K. Yeah, just to make this easy to see, I want to change K to 1. Let's do this again. So here are my diagonal scores, and I have one at index 3, one at index 4, and one at index 7. So 0, 1, 2, 3, that would be this diagonal right here, and then 4, and then 5, 6, 7 is that one. So, and then the rescore diagonals should be the same thing, except the scores have changed. And what I want to do now is test to see if calculate regions. Oops. Did what I set out to do. No instance for show region. That's because there's no instance for show region. Okay, so actually, before I even try to figure out if it worked or not, I'm just gonna make the gap penalty, the gap start penalty 5. So I'm just gonna artificially make it so that this joining these two diagonals is gonna be worth it. So I'll say like the gap penalty is 5. So it'll be 10 plus 10, so 20 minus 5 is 15. That's better than either original diagonal of 10. But I want to make this joining not worth it for this one. So I'm going to say the gap extension penalty is like 100 or something, so that the only diagonals that want to join with each other are these two. And so I should have some mix of, well, I should basically have two double diagonals as regions, which would be this diagonal being replaced by this region, this diagonal being replaced by this region, and then this diagonal is going to remain a single diagonal region. So I'm just going to make gap extension penalty 100. Should those be positive? No, those should be positive or negative? Let me figure this out real quick. I'm adding gap penalty, and so so they should be negative. Yeah. Okay. Oops. Alright, so the index 3 one was replaced with a double diagonal. The index 4 was replaced with a double diagonal, and the index 7 one remained a single diagonal. So it worked. Hooray! Alright, thanks for watching. See you next time.